In electromagnetic wave, next we will discuss the nature of electromagnetic waves. First is electromagnetic waves are transverse in nature. That is, electric field, magnetic field, and direction of propagation, which is mentioned by the vector k, this is the propagation constant, are mutually perpendicular. And this transverse nature is evident from the property of polarization, which is shown by the electromagnetic waves. And it is to be noted that direction of polarization is taken parallel to the electric field. Second is, if we graphically represent the electromagnetic wave, and this is the say z-axis, which is the direction of propagation, and it is x-axis, which is showing, which has the electric field along the direction x, and another direction is the y direction. Now the electric field is mentioned in this way, and electric field vectors are shown in the diagram. These are electric field. This electric field mathematically can be written as Ex, that is equal to E naught, this is the maximum value of the electric field, sine kz minus omega t. Here k is the propagation constant, it gives the direction of propagation, and it is equal to 2 pi by lambda, where lambda is the wavelength, and omega is the angular frequency. Its value is given by 2 pi by capital T, where T is the time period, or 2 pi nu, where nu is the frequency of the wave. And velocity of the wave, V is the velocity of wave, and it is equal to omega by k. That is the ratio of angular frequency, and the propagation constant gives the velocity of the electromagnetic wave. And if we write it, it is 2 pi nu, and k is 2 pi by lambda, so we can write it as nu into lambda. Now we draw the magnetic field, variations of magnetic field. So magnetic field is represented by in this way, and the direction of B will be perpendicular to E. So in this way we can represent the magnetic field vector. So magnetic field vector B, electric field vector E, and direction of propagation are mutually perpendicular. We can write the magnetic field vector in the form By equal to B naught, this is the maximum value or the peak value of the magnetic field, into sine kz minus omega t. Here it is to be noted that if kz and omega t are of opposite sign, then it means the wave is propagating in plus direction of the, because variable is z, plus z direction. If both are of same sign, then we will say the direction is the minus. Here we have to note two important points, that direction of propagation is along the cross product of vector E and V. This is very important. We have to note that and to memorize. Another is the speed of light, that is c, or the electromagnetic wave, is equal to E by B. That is the ratio of the electric field and the magnetic field. So these two property we have to remember, and they will be very useful in solving many of the problems. That is, the propagation constant or the direction of propagation is along the cross product of E cross B, and the speed of the electromagnetic wave is the ratio of electric field and the magnetic field. Next property is that electromagnetic waves do not require material medium for propagation. That means speed of the electromagnetic waves in the vacuum is 1 by square root of mu naught epsilon naught, and it is approximately equal to 3 into 10 power 8 meter per second. It is in vacuum. In other material medium, if we find the speed of light, then this speed of the electromagnetic wave will be equal to 1 by square root of mu epsilon, where mu is the permeability of the medium and epsilon is the permittivity of the material medium. Another property is that electromagnetic waves carry energy, say E, momentum P, and exert pressure. For example, P equal to E by C. The relation between the momentum and the energy for an electromagnetic wave is given by the relation P equal to E by C. So we have to remember this formula. Another point is that electromagnetic wave is a wave also exhibit particle nature, that is have the dual nature. Properties like refraction, diffraction, polarization, etc. are exhibited by the wave nature. Similarly, it has particle nature also, that is the electromagnetic wave is composed of photons, the energy packets, and energy of energy packet is h nu, that is equal to hc by lambda. So on the basis of this particle nature, the property which can be explained is photoelectric effect. Next property is energy density of electric field UE, that is equal to half epsilon naught E square. And similarly, energy density of magnetic field in an electromagnetic wave UB is equal to 1 by 2 mu naught into B square. Now we will do some problems.